Hello everybody, my name is Christoph Wichmann, and in this video I would like to explain how you can set up Mutual-SSL authentication on the Axway API Management platform, or at least one possible way, of course. This video is based on an AWS EKS Kubernetes cluster, which comes with some specials, which I would like to explain as part of that video. Let's say in a standard installation, in a classic installation, some of the steps you will see in this video are not necessary, or the approach might be a little bit different one. First of all, when the API gateway handles traffic, it points to, let's say, a certain listen socket, which is here in an HTTPS socket, port 443. And here all clients are performing the SSL handshake. And that port for Mutual-SSL needs to support to accept or require client certificates to perform the Mutual-SSL authentication. And for this Mutual-SSL authentication needs to be configured as the initial step in Policy Studio. So in Policy Studio, you go to the environment configuration for that API Gateway project in Listeners, API Gateway, and this is the API Manager Traffic Listener group, which represents that traffic port you have just seen, or that traffic URL, basically including the port. And here in the port section, we have that responsible HTTPS listen socket where all the clients are connected to when they would like to call an API. And this needs to be configured to support mutual authentication. By default, it is configured to ignore client certificates. But in our case, as we would like to add support for that, we say accept client certificates. I do not say require client certificates, because that would mean that all of the APIs have to have two-way or mutual SSL authentication. So I'll say accept client certificates, which allows client to send me their client certificates, and you will see later in the video how we can make use of that. The next thing I could do is to select already in this dialog the trusted certificates, trusted certificate authorities of all client certificates you would like to accept. I skipped that because I configure the trusted certificates in API Manager directly. So that means that's all I have to do in Policy Studio. And after it is deployed, that port, which is in reality by default port 8065, is now supporting that way of mutual authentication. But as we are in a Kubernetes cluster, things might be a little bit more difficult, because by default, that resource is actually configured and controlled by an ingress resource, and that ingress resource turns into an application load balancer. And that application load balancer is then terminating the SSL handshake, makes the SSL offloading. And due to that, the API gateway traffic port running in Kubernetes doesn't see the client certificate anymore. So that means when I'm checking that application load balancer, which I called the Axway API Management Ingress, and going to the default port 443 for the rules, then I can see this is actually handling the traffic and forwards them to the correct Kubernetes service at the end. All this, of course, based on Kubernetes configuration, and then all this is self-provisioned. So, and one way now to solve that is either, or not either, let's go that way, is to set up maybe an additional service which has a different type and is not an ingress resource. And this is what I have done in my Kubernetes cluster. Let me show you, let's say, the services which are actually in place. I have that traffic service, which is the one which is used by the ingress resource as a backend for including the port for the API Manager traffic 8065. And additionally, I have now created a new service which I called the Mutual-SSL traffic service, which is exposing the same um, port 8065, but in a different way. So let's have a look into that one. This service is defined over here. So that means we see the name, then we see the target port is the same. This is for the API gateway. And we have then this port made available externally as part of the service with the port 443. And it should be forwarding requests to all pods having the selector app equals to traffic. And it is from the type load balancer. And together with these annotations over here, a network load balancer is provisioned in AWS. And that network load balancer is not doing then the SSL termination anymore and is forwarding the traffic, including the client certificate, directly to my API gateway. So let's see how that looks. So just by removing the filter. Now this is the network load balancer I have created. It has only that listener and forwards the traffic to that target group, which has been provisioned in the background. Finally, it is talking to the same or to the service you have just seen. So, and with that, there's one more thing. I have configured for that load balancer over here. I have configured an additional DNS name because now I need to make a distinction between, let's say, the normal traffic, which goes to traffic, Axway, Amplify, Central. It's an interesting name, central.com, and traffic that should support Mutual-SSL. And for that, I have a new, just go back here. I have an additional DNS name, and that DNS name is now pointing to the Mutual-SSL, to the network load balancer at AWS. So, and let's give it a try. Let's see what happens. So now it's saying connection reset, and if you would dig into the details, you would see that the SSL handshake basically fails. So, and this is because we have at the moment no trusted certificates configured at all for the ports. So let's go and reconfigure that API to support Mutual-SSL. We say that the inbound security must be two-way SSL. So what is this? This is the API key field name of the certificate. That means at runtime, we are taking the common name from the certificate and consider that as to be the API key. We will see what that means in a minute. Then the next thing, what I'm going to do is to add trusted certificates for that API. So that means if you have a number of APIs and all of these APIs are trusting the same CA, of course, you could do the same thing in Policy Studio and just configure that trusted CAs directly here. But in my case, just to show that possible option, we say that the certificate should be added over here. This is my root CA, and I would like to make that used for the inbound. So, and then we save that. And now let's see if there is any difference. Now the process is executed and we are getting a response from the pet store. Let's see what happens in reality. So when I go now into the API Gateway Manager, I can see that call has been executed by the application test, find pets by status. So, and the application test was because my certificate I have used as the client certificate here in Postman. I have configured that in Postman certificates, and I have defined whenever you talk to that endpoint, you use that partner A client, the partner A client certificate. And this partner A client certificate has a common name, and that common name has been picked at this point here, and then it has been mapped to an application. So that means it scanned all the applications, and the application that has this external client ID has been identified as the application belonging to that partner, belonging to that application. And if I turn off that client ID, I can now try it again. And now I'm getting a security failure. And if I go into the API Gateway Manager, I can see that it is that the all authentication device has been failed. Or if I make it a different way and say that this application, but this application has no access to my API, let's do it like so. Then I'm getting a forbidden. And if I check the API Gateway Manager traces again, I'm now seeing that the application is not authorized. Application test with that ID not authorized to access the API pet store. So one more thing concerning that successful request. So let's say I have access to that API again, and I call that now again, because sometimes it might be useful because now we know which client certificate has been used to call that API. And that client certificate may contain additional attributes you have as you have issued that client certificate, and now you would like to perform authorization or anything. You have information about that certificate as part of your execution context. So that means directly after the Mutual-SSL authentication was successful, information about that certificate has been ejected into the execution context. That's why I can now go here and check for some attributes, and I can see there is an authentication certificate. This contains now the certificate of the client. What was the issuer of that certificate? It was from the partner root CA, and so on. And if you need more information about that certificate, you can grab more information from the internal certificate store, for instance, with a filter, extract certificate information and make it part of your policy. But you have already the most important information, what was the certificate at runtime, and then you can make additional lookups or whatsoever. So that was basically everything I wanted to show about how to set up Mutual-SSL on an AWS EKS cluster. There's one important information. Instead of having an application load balancer for including the rule for the traffic, it would also be an option to say we are removing that traffic resource from the ingress controller and let all traffic go to a network load balancer. That would be the other option. And then you only have specific resources like for the gateway or like for the manager on that application load balancer only. So but to avoid that you have to use two different host names for your APIs. So that's all I would like to explain. Thanks for watching.